Hi friends, in this video we are going to learn about Cayley-Hamilton theorem. The statement of Cayley-Hamilton theorem says that every square matrix, that is number of row and number of columns are equal. Every square matrix satisfies its own characteristics equation. For example, let's say here I am writing, let's say A is my matrix of order 2 cross 2, that is A11, A22, that is A21, this is A22. So this is square matrix of order 2 cross 2, and the characteristic equation of this matrix is, here I am writing the characteristic equation, that is the determinant of A minus lambda I equal to 0. So this is same as lambda square minus trace of A into lambda plus determinant of A equal to 0. Here trace of A is sum of the principal diagonal entries, that is A11 plus A22. So here A11 must be some scalar, A22 is scalar. So let's say here I am giving this as C1, and determinant of this matrix is here A11 into A22 minus A22 into A21. Let's say this is some scalar C2. This is some constant and this is some constant scalar, that is C1. This is scalar, that is trace, and this C2 is the scalar, that is determinant. So here this equation 1 becomes lambda square minus trace is C1 and this is matrix A minus that plus determinant of A, that is C2, which is equal to 0. Here this is the characteristics equation of this matrix. Here A is a very general matrix of order 2 cross 2. So here Cayley-Hamilton theorem says that every square matrix satisfies its own characteristics equation. So means if I substitute in place of lambda my matrix A, that is A square minus C1 times A plus here now this is my constant C2. So here this is A square, A is a matrix of order 2 cross 2, A square must be a matrix of order 2 cross 2. This is matrix. So here multiplying C1 with matrix, again this is a matrix of order 2 cross 2. This term is a matrix of order 2 cross 2. This term is a matrix of order 2 cross 2. Here I am operating matrix. So here this must be a matrix of order 2 cross 2. Here in place of C2, here I am writing C2 into I. Here I am converting this scalar into the matrix by multiplying the identity matrix to C2. So here now this, so now this must be a matrix of order 2 cross 2. Now this is matrix of order 2 cross 2. So this is matrix of order 2 cross 2 and this is matrix of order 2 cross 2. After performing this operation, minus plus, this whole term is a matrix of order 2 cross 2. So here this is equal to, now this is my 0, this is some scalar. Here left hand side is a matrix of order 2 cross 2. I want right hand side must be a matrix of order 2 cross 2. Here I am multiplying 0 into identity matrix of order 2 cross 2. Here I am multiplying this 0 by identity matrix of order 2 cross 2. So here right hand side must be matrix of order 2 cross 2. Now this equation in terms of matrix is, now here, now this is the equation in terms of matrix. Now this is the equation in terms of scalar. Say lambda square minus trace of A into, sorry, this is my lambda, plus here lambda square minus trace is C1 into lambda plus determinant of A is my C2. So here this is my lambda, some scalar, minus this is some constant, this is lambda, this is C2. So this is characteristics equation in terms of lambda, and this is the characteristics equation of this matrix in terms of, here this is matrix. So here if here Cayley-Hamilton theorem says every square matrix satisfies its own characteristics equation, means here right hand side, so this is the, here again I am writing A square minus C1 times A plus C2 into I. So here I, which is equal to 0 into identity matrix. Here this is a 0 matrix of order 2 cross 2. This now, this is not a scalar 0, this is a 0 matrix of order 2 cross 2. Here I am multiplying identity matrix by 0. Here 1 0 0 1 becomes 0 0 0 0. Now left hand side is a matrix and right hand side is a matrix. So here if this matrix satisfies its own characteristic equation, means left hand side must be a 0 matrix of order 2 cross 2. So here I will prove, here I will show how this I will show this calculation here with the help of this matrix A. So here this question one says that verify the Cayley-Hamilton theorem. CST stands for Cayley-Hamilton theorem, and show that a power 8 equal to 625 times identity matrix I, where A is my this matrix. So here first of all write the characteristic equation of this matrix. Here the characteristic equation of this matrix is, that is characteristic equation is here determinant of A minus lambda I, which is equal to 0. This is same as lambda square minus here trace of A into lambda plus determinant of A equal to 0. Here trace of this matrix is 1 minus 1, that is here A11 position plus A22 position, 1 minus 1, which is equal to 0, and determinant of this matrix equal to here minus 1 minus 4, which is equal to minus 5. Just put this value in the here lambda square trace is 0, means this whole term is 0, minus determinant is here this whole term is 0. Here I am writing this whole term is 0. Here this is here trace means 0 into lambda plus determinant is minus 5, which is equal to 0. This is same as lambda square minus 5, which is equal to 0. Now this is the characteristic equation of this matrix A. Now this is equal to this. Here trace is 0 and determinant is 5. Here my C2 is minus 5. Now I want to convert this matrix into this characteristic here. But according to Cayley-Hamilton theorem, every square matrix satisfies its own characteristic equation. That is, here I am writing A square minus here this my 5 is my scalar. Here I want to convert here A square, A is matrix of order 2 cross 2. A square must be a matrix of order 2 cross 2. So here this is matrix. So I want here again matrix. So here I am multiplying 5 to the identity matrix. So now this becomes, now this is also matrix of order 2 cross 2. Now this is matrix of order 2 cross 2. This is matrix of order 2 cross 2. This matrix subtraction is feasible. Now here I am multiplying identity matrix of order 2 cross 2 to this 0. So here after that, here after multiplying identity matrix of order 2 cross 2 to this 0 becomes matrix of order 2 cross 2 having all entries are 0. Means 0 0 and 0 0 entry. Now this is the characteristic equation in terms of matrix. Here Cayley-Hamilton theorem says every square matrix satisfies its own characteristic equation. Means here this is matrix of order 2 cross 2 having all entries are 0. Now if I am able to prove this A square minus 5i is again matrix of order 2 cross 2 having all entries are 0, 0 0 0 0. Now find the A square, that is A square here. So I will give this as equation 1. A square equal to A into A, which is equal to, here A is 1 2 2 minus 1, and here again 1 2 2 minus 1. Here this is my A square. Now here 1 into 2 1 and 2 into 2 4. 1 plus 4, that is 5. Here 2 1 into 2 2, and this 2 into minus 1 minus 2 plus 2 minus 2, this is simply 0. Now this is 2 into 1 2, and this is minus 1 into 2 minus 2. 2 plus 2 minus 2 gets cancelled, so this is 0. So this is 2 into 2 4, and plus minus 1 into minus 1 plus 1, this is 5. So this is my A square. Now calculate 5 into I. So here I is identity matrix. So here 5i is 5 0 0 and 5. Now here I will rub this. So here equation 1 becomes that is A square minus 5i. Here A square minus 5i equal to is a 0 matrix of order 2 cross 2. A square is right here. A square is 5 0 0 5. Here minus 5i, that is 5i is 5 0 0 0, and here I will write here. Now this matrix here, this is a 0 matrix 0 0 0 0. Now here matrix subtraction, 5 minus 5 0, 0, 0, 0. So which is equal to 0, 0, 0, 0. So here left hand side equal to right hand side. This means that this matrix A satisfy its characteristics equation lambda square minus 5i, that is a square minus 5i equal to 0. Therefore A satisfy its own characteristics equation. Now here we verify this Cayley-Hamilton theorem in terms of matrix A. Now they are saying show that A power, after if this matrix satisfies its own characteristic equation, then show that A power 8 equal to 625 times I. Here from equation 1, from equation 1, can I write A square equal to 5 times I? So here I am raising the power of here A square into 2. So here 5 square. Identity matrix square is here. This is 5 square. This is identity matrix square is again identity matrix. So this is same as 25 times I. So here this means A power 4 equal to 25 times I. Again raise power to A power 2 4 into 2, which is equal to 25 times square. This is identity matrix square is I, again I. So this is same as 625. 25 square is I. So therefore A power 8 equal to 625 times I. So that's we want. Here in this way you can calculate. Here whenever they are giving verify the Cayley-Hamilton theorem is find the characteristic equation. So just put here in this characteristic equation in terms of matrix a square minus 5i equal to 0, and this is 0 matrix of order 2 cross 2. So after writing in terms of matrix, so we want this is also 0 matrix of order whatever. Here a square, this is 5i, just put this value. Here we got a square minus 5i 0, 0, 0, 0. Here left hand side is 0 matrix of order 2 cross 2, right hand side 0 matrix of order 2 cross 2. Hence my matrix A satisfies its own characteristics equation. That means Cayley-Hamilton theorem is verified. Thank you.